हेलो एवरीवन, काइनेमैटिक्स की लेक्चर सीरीज 2 में आपका स्वागत है। और इस लेक्चर सीरीज में हम लोग डिस्कस करेंगे दो चीज़ें, एक्चुअली एक ही चीज़, वेलोसिटी और हमारा जो भी डिस्कशन होगा वो वेलोसिटी पे ओरिएंटेड होगा। लेकिन वेलोसिटी जो है वो दो तरह की होती है। देयर आर टू टाइप्स ऑफ वेलोसिटी। एक होती है एवरेज वेलोसिटी और दूसरी होती है इंस्टेंटेनियस वेलोसिटी। Now, what is the difference between average velocity and instantaneous velocity? Now, what is the concept of velocity? हम वहां से शुरू करते हैं। Velocity is displacement per unit time, and that is a very basic definition of velocity. ये वो डेफिनेशन है जो कि आपने क्लास 9th और 10th में पढ़ी है, दैट इज डिस्प्लेसमेंट बाय टाइम। अब इसमें मैंने जैसे कि कहा आपसे कि दो तरह की वेलोसिटीज होती हैं। सो द फर्स्ट वेलोसिटी इज एवरेज वेलोसिटी। क्लास 11th में, in class 11th we will use a new type of notation to denote average velocity, and the average velocity will be denoted by these strange looking brackets जिसका generally use आप mathematics में नहीं करते हो, and this is something that we define as average velocity, and average velocity is simply displacement by time, nothing else. एंड व्हाट इज डिस्प्लेसमेंट? डिस्प्लेसमेंट क्या है? डिस्प्लेसमेंट आपने अगर लास्ट लेक्चर सीरीज देखी है और अगर नहीं देखी है तो मैं चाहता हूं कि आप वापस जाकर के ये क्लियर कर लें कि डिस्प्लेसमेंट क्या होता है। तो डिस्प्लेसमेंट इज फाइनल पोजीशन माइनस इनिशियल पोजीशन डिवाइडेड बाय टाइम। नाउ लेट मी एक्सप्लेन दिस विथ एन एग्जांपल। Let's say we have a single straight line and a particle is moving in a single straight line. These are the points on the straight line: 0, 1, 2, 3, 4, 5, -1, -2, -3 and -4. Now a particle starts from 1, goes to 5 and returns back and stops its motion at -4. This is the entire motion of the particle. मैं फिर से बता दूं, the particle starts from x equals to 1, goes to x equals to 5 and then returns back and ends its motion at -4. This is the motion. Now let's try to denote some time over here. This was t equals to 0. This was t equals to 2 seconds. It returned back at the starting point at t equals to 4 seconds. And it reached -4 at t equals to 6 seconds. And these are the instances of time where the particle is at. So the particle is at x equals to 1 at t equals to 0. Let me draw this with a table. So t versus x. At t equals to 0 seconds, it is at x equals to 1. At t equals to 2 seconds, it is at x equals to 5. At t equals to 4 seconds, it is back at x equals to 1. And at t equals to 6 seconds, it is at x equals to -4. So this is the table and this is how the particle is moving. Now if someone asks you, कोई आपसे पूछता है कि what is the average velocity between 0 to 2 seconds, 0 सेकेंड से 2 सेकेंड्स के बीच में एवरेज वेलोसिटी कितनी है, तो आप सीधा सीधा क्या कहोगे, एवरेज वेलोसिटी इज डिस्प्लेसमेंट बाय टाइम, that is final position minus initial position divided by time. And let's see what is the final position at 2 seconds. Final position is 5, initial position at 0 seconds, that is 1, and divided by time, and that is equals to how much, between 0 to 2 seconds, that is equals to 2. So the average velocity is 2 meter per second. Now someone can also ask you, what is the average velocity of the particle between 0 to 4 seconds? So the average velocity would be again displacement by time, that will be final position minus initial position by time, that will be final position at 4 seconds is 1, initial position at 0 seconds is also 1, divided by the time, that is t equals to 4, and we have 0 meter per second. The average velocity between 0 to 4 seconds is 0 meter per second. Now someone can ask you a third and final question. There are more questions possible, but I am just discussing 3 questions. What is the average velocity between 0 to 6 seconds? Again, the average velocity will be equals to displacement by time, that will be equals to x final minus x initial divided by time, that will be again final is minus 4, initial is 1, divided by time is 6, and that will be equals to minus 5 by 6 meter per second. So this is how you calculate the average velocity. अब calculate करने का तरीका तो समझ में आ गया. Now how do we explain what average velocity is, or how do we define what average velocity is? So from these calculations we simply define average velocity as total displacement in a time period divided by the total time period. And this is how we define average velocity. As a matter of fact, we can also define average velocity in 2 dimensions, also in 3 dimensions, लेकिन 3 dimensions नहीं लेंगे, just let's focus on 2 dimensions. So let's say this is our x-axis, this is our y-axis, and the particle was initially at 1,4. It starts to move here, something like this, and it ends its motion at 4,1, and it takes t equals to 2 seconds to do so. तो पार्टिकल आपका स्टार्ट हुआ 1,4 से, मूव किया 4,1 तक, और ऐसा करने के पूरे प्रोसेस में उसने लिया 2 सेकेंड्स. तो एवरेज वेलोसिटी हम कैसे निकालेंगे? एवरेज वेलोसिटी निकालने का तरीका है, दिस इज योर आर इनिशियल, this will be your R final position, this will be your displacement. Let me show this with a different color, this in red color maybe. Okay, so this is your displacement, and the average velocity will be actually equals to displacement by time, or we can simply say final position minus initial position divided by time. So final position, if in vector format, is 4 I cap plus j cap. Initial position in vector format is I cap plus 4 j cap. and the time is 2 seconds as given in the problem. So the average velocity in vector format is going to be 3 I cap minus 3 j cap divided by 2. Or if you want to find out the value, the magnitude of average velocity, this is the representation of magnitude. The magnitude of average velocity would be equals to root under 3 square plus 3 square divided by 2. So 3 square plus 3 square divided by 2. This 2 here, this 2 is here, and the value of this is root under 3 square plus 3 square. So you will have 3 root 2 by 2, or simply 3 upon root 2 meter per second. This is just the value of average velocity. Value of average velocity. It does not have any direction because we are just calculating the value. But if you want the entire vector, this is your complete vector, this is your average velocity vector. This is your average velocity vector, and this is a way to calculate the average velocities. Now we can do some problems on average velocities. Problems on average velocities. A first interesting problem would be a particle moving in straight line moves the first half of distance with speed or velocity v1, and the second half of distance with velocity v2. Find the average velocity of the motion. Now we have to solve this. I want you to pause this video and look at this question. एक हो सके तो एक बार खुद से ट्राई करो सॉल्व करने का, अगर नहीं तो कोई बात नहीं, इट्स ओके. सो पॉज दिस एंड सी दिस. चलो, तो आपने ट्राई कर लिया, अब हम देखते हैं हम इसे कैसे सॉल्व करेंगे. सो वी हैव अ स्ट्रेट लाइन फ्रॉम ए टू बी and the particle is moving along this straight line. We are assuming कि हम ये assume कर रहे हैं कि particle return नहीं हो रहा है, it is just moving directly from A to B. That is a general assumption. ये question ले रहा है और इस assumption को इसमें मानना पड़ेगा. Now the first half of the distance, let's say d by 2. D is the complete distance. Let me mark this with a separate color. D is the complete distance. So now the first half of distance is covered with a speed v1, and the second half of the distance, that is d by 2 again, is covered with a speed v2, and you have to find the average velocity. So if I want to find the average velocity, I need the total distance that I have already assumed, which is d, and I need the total time, or in other words, I need t1 plus t2. The time taken to cover this part of the distance is t1 and the time taken to cover this part of the distance is t2. अब ये कैसे करेंगे? It's actually very simple. Since the particle is moving in the constant velocity, ध्यान देना, इस यहाँ पे velocity change नहीं हो रही, लगातार v1 है. So since it is moving with constant velocity v1, the time taken is going to be d upon 2v1. Distance by speed. Second, the same process, d by 2v2, that is the time t2. So t1 is actually equals to d by 2v1 and t2 is equals to d by 2v2, because in both cases the particle is moving with a constant velocity. Now it's just a matter of solving this, so we can cancel out d and we can write this here 2v1 v2 upon v1 plus v2, and that is your average velocity from point A to point B. Now I don't want you to take this for my word, थोड़ा सा mathematical manipulation लग रहा है. I want you to solve this properly in your own notebooks and see if you are getting the answer. Okay, let's move forward. A particle is moving along a straight line with constant velocity v1 in first half of the distance in the second half of distance the particle is moving with velocity v2 for first half of time and v3 for second half of time. Find the average velocity for the motion. Okay, so now this question is slightly more complicated than the last one, and let me first explain to you what the problem means. Okay, so a particle is moving in a straight line just like the last one, no problem there. It starts from A, it goes to B. Let's say the entire distance between A and B is d, that is also no problem. Now I divide the distance into two parts. This is the first half, that is d by 2, and the particle moves with a speed v1 in this first half. In the first half of the distance, the particle moves with a speed v1. Now what happens in the second half of the distance? Now this is very important. If you look at this question here, something complicated is happening. In the second half of distance, the particle is moving with velocity v2 for first half of time and v3 for second half of time. अब इसका मतलब क्या है? इसका मतलब ये है कि हमारी जो डिस्टेंस सेकेंड हाफ की डिस्टेंस है, दैट इज d by 2 रिमेनिंग डिस्टेंस, उसे हम दो हिस्सों में बांट देंगे. वी डिवाइड d by 2 into two parts. Divide this d by 2 in two parts. But these two parts will not be two parts of distance, but they will be two parts of time. उसे डिस्टेंस के हिसाब से मत बांटो, उसे टाइम के हिसाब से बांटो. अब इसका मतलब क्या हुआ? इसका मतलब ये हुआ कि मान लेते हैं कि यहां से लेके यहां तक, इस जगह से लेके इस जगह तक, यहां से लेके यहां तक टोटल टाइम लगता है t. तो इसे दो हिस्सों में बांट दो अगर, तो ये टाइम हो गया t by 2 और ये टाइम हो गया t by 2, और इस टाइम t by 2 में द वेलोसिटी इज v2 और इस टाइम t by 2 में द वेलोसिटी इज v3. नाउ आई एम नॉट श्योर कि these two distances are equal or this is smaller or this is larger or maybe this is larger or this is smaller. I have just drawn a case. वो कुछ भी हो सकता है. ये भी हो सकता है कि ये मिडिल में हो, ये भी हो सकता है कि ये छोटा हो, ये बड़ा हो, या ये भी हो सकता है कि ये बड़ा और ये छोटा हो. बट दैट इज नॉट आवर प्रॉब्लम. ठीक? Again, let me explain this. we are not dividing this distance in two parts of distance. We are dividing this distance in two parts of time. So if the total time from the middle point to B is t, then half time the particle is covering with velocity v2, and the second half of time the particle is covering with a velocity v3. Okay, and that is what is happening over here. So let's see how that happens. So I'll leave the diagram. Now we want to find out the first time. The first time t1, this time here, is actually going to be d by 2v1. And then we want to find out the second time. Second time is this entire time here, this entire time from here to here, and that time is what we are calling as t. So that second time I can, how do I find out the second time? Actually it is simple. If you see here, this ये जो particle है ये t by 2 time लेता है with a speed v2, और ये फिर t by 2 टाइम लेता है विद अ स्पीड v3. तो इसकी जो टोटल डिस्टेंस है वो d by 2 के बराबर है. तो इसे करने का दूसरा तरीका एडॉप्ट करेंगे, v2 into t by 2 plus v3 into t by 2. What are we doing here? We are doing speed into time equals to distance, and the total distance is equals to d by 2. Now what we can do is this, we can cancel out this 2 and this 2 here, and what are we going to get? We are going to get t equals to d upon v2 plus v3. Now it's time to find out the average velocity, the total average velocity, and the total average velocity will be total distance by total time, that will be t1 plus t, and that will be equals to what? That will be equals to d, let me make more space in the screen here. So d upon 2v1 plus d upon v2 plus v3. Now how do you solve this? It's actually simple. You multiply these two and then you cross multiply, you take the denominator over the top, and this is what you are going to get, 2v1 v2 plus v3 divided by v2 plus v3 plus 2v1, and that is your average velocity. Now in this section I want you to think, is average velocity let me write down this question for you. Let me pose this question, and it's a very important question. Is average velocity a correct description or depiction of the motion of a particle? Or in other words, I would rather not use the word correct, I would use the word exact. Exact depiction of the motion of the particle. क्या average velocity से हम particle का exact motion निकाल सकते हैं? And let me explain this to you. मान लो पार्टिकल ने यहाँ से मूव करना शुरू किया, यहाँ पे पहुँचता है. ठीक है भाई, अच्छी बात है. दिस इज t इक्वल्स टू 0. वो पहला 1 मीटर कवर करता है. दिस इज 1 मीटर, लेट्स से. पहला 1 मीटर कवर करता है 1 सेकेंड में. अगला 1 मीटर कवर करता है. दिस इज 1 मीटर in t equals to 0.5 seconds. अगला 1 मीटर कवर करता है in t equals to 1 seconds. अगला 1 मीटर कवर करता है in t equals to 1.5 seconds. और आखिरी 1 मीटर कवर करता है in t equals to 0.5 seconds. अब अगर आपसे कहा गया कि फाइंड आउट द एवरेज वेलोसिटी, तो आप क्या करोगे? यू विल टेक द टोटल डिस्प्लेसमेंट, दैट इज 1 मीटर plus 1 meter plus 1 meter plus 1 meter. How many of those we have? So 1, 2, 3, 4 and 5. So 1, 2, 3, 4 and finally 5 plus 1 meter divided by the total time, that is 1 second, 0.5 seconds. Let me add all the time. So 1 plus 0.5 plus 1 second plus 1.5 second plus 0.5 seconds. So if you are going to find out the average velocity, it is actually going to be equals to 5 divided by 1.5, 1.53, 3.5 plus 1, that is 4.5. So 5 meters in 4.5 seconds, or you can simply simplify this, 45. So 10 divided by 9, or 1.11 meter per second. Now this is what average velocity is. ठीक, लेकिन I want you to understand here, अगर आप सिर्फ इस पार्ट के लिए एवरेज वेलोसिटी देखो, फर्स्ट पार्ट के लिए, तो फर्स्ट पार्ट के लिए एवरेज वेलोसिटी कुछ और ही है. एवरेज वेलोसिटी इन द फर्स्ट पार्ट इज एक्चुअली इक्वल्स टू 1/1, दैट इज 1 मीटर पर सेकेंड. अगर आप सेकेंड पार्ट के लिए देखो तो एवरेज वेलोसिटी कुछ और है. सेकेंड पार्ट के लिए आप देखो, इट कवर्स 1 मीटर्स इन 0.5 सेकेंड्स. So 1 meter divided by 0.5, and that is equals to 2 meter per second. And if you will look at each part separately, you will find that की particle की average velocity different होती जा रही. The particle will have different average velocities. Let me mention this here. The particle will have different average velocities in different parts of motion. And why is this a problem? This is a problem because if you start breaking it even into smaller parts, so let's say if you start breaking it into 0.5 meters, into smaller parts of 0.5 meters, you will see that the particle's velocity may vary even more. There will be more variations. And if you divide it into further smaller parts, let's say 0.25 meters, you will see that there are even more variations of average velocity. So what is happening with average velocity is this. In average velocity, and this statement is actually very important, in average velocity, we never take into account the variations happening in smaller parts of the motion. Now you see, this is not exactly how motion is represented. जैसे मान लीजिए कि आपने अपनी बाइक उठाई और आपको पॉइंट ए से पॉइंट बी जाना है, तो ऐसा बहुत बार होगा कि you will have to come across a traffic signal and there is a red light, okay, and there is a red light and you will stop, or maybe there is a speed breaker and then you have to apply your brakes, or maybe the traffic is busy, maybe it's peak traffic time, peak traffic hours. तो देन यू विल हैव टू गो विद मोर स्पीड सम प्लेस एंड लेस स्पीड सम प्लेस. तो जहाँ आपको जगह खाली मिलेगी आप तेज़ी से भगाओगे, जहाँ आपको जगह खाली नहीं मिलेगी, जहाँ पे आपको ट्रैफिक मिलेगा, आप वहाँ उतनी तेज़ी से नहीं जा सकते. तो आप ये पाओगे कि एक मोशन में आप वो मोशन कितना भी छोटा कर लो, आप 5 मिनट का भी एक मोशन कर लो, तो एक्चुअल जो मोशन है उसमें वेरिएशन हमेशा एग्जिस्ट करता है. और एवरेज वेलोसिटी में हम इस वेरिएशन को कभी अकाउंट में लेते ही नहीं हैं. एवरेज वेलोसिटी में हम इस वेरिएशन को कभी भी अकाउंट में नहीं लेते हैं. दिस इज द प्रॉब्लम विद एवरेज वेलोसिटी. ओके, तो in order to solve this situation, we come up with a newer form of velocity, and that is what we call as the instantaneous velocity. Now, how do we account for instantaneous velocity? It's actually very simple. Instantaneous velocity, let me write this as a statement. Instantaneous velocity is an average velocity calculated for very small intervals of time. Very small intervals of time. If you have seen my lecture on calculus, then you will understand what I'm talking about. If you haven't, please go see that, because that's an interesting lecture over there. So small intervals of time, and those small intervals of time I will represent them with dt. अब इसका क्या मतलब हुआ? Let's say at t equals to 1 second, the particle is at x equals to 2 meters. Alright? And now what do? We do is we blow up this diagram a bit, और हम इस t equals to 1 second के बहुत पास, इस t equals to 1 second के बहुत पास, बहुत करीब, t equals to 1.001 second पे हम पार्टिकल की पोजीशन देखते हैं, that is let's say x final equals to 2.004 meters. ओके तो हम अपने टाइम गैप को बहुत छोटा कर देते हैं. देखो 1 सेकेंड और 1.001 सेकेंड, 2 मीटर्स और 2.004 मीटर्स. तो टाइम गैप को छोटा कर देते हैं, तो ऑब्वियसली डिस्टेंस गैप भी बहुत छोटा हो जाता है. सो वी हैव टू कंसिडर स्मॉल इंटरवल्स ऑफ टाइम. लेट मी कम बैक. सो वी हैव टू कंसिडर स्मॉल इंटरवल्स ऑफ टाइम and small intervals of distance. So average velocity for small intervals of time, that is let's say displacement by time. So instead of writing big displacement, we will use small displacement by small time. Now what is small displacement? Small displacement is final position minus initial position. कुछ भी नया नहीं कर रहे हैं, सब कुछ वही कर रहे हैं जो हमें पहले से आता है. Small interval of time is t final minus t initial. Now final minus initial, I'm sorry, this is final minus initial. Now what is final minus initial? Final position minus initial position. So final position is 2.004 minus initial position is 2. Time final is 1.001 minus initial position is 1 seconds. And when you subtract it, you will get 0.004 divided by 0.001, and if you solve it, you will get it as 4 meters per second. And this is what we call as an instantaneous velocity. इसी को हम instantaneous velocity बुलाते हैं. तो किसको instantaneous velocity बुलाते हैं? ऐसी एवरेज वेलोसिटी को जिसमें हमने टाइम इंटरवल को बहुत छोटा कर दिया. तो बहुत छोटा करने से फायदा ये होगा कि उसमें जो वेरिएशंस होंगे हम उसे अकाउंट कर लेंगे. जैसे पहले क्या हो रहा था? पहले हो रहा था अगर आपने 15 मिनट तक गाड़ी चलाई, आप मान लीजिए आपने गाड़ी यहाँ से लेके यहाँ तक चलाई, तो आपकी वेलोसिटी में बहुत सारे वेरिएशंस थे. यहाँ पे आप मान लो चल रहे थे 2 मीटर पर सेकेंड से, यहाँ पे आप चल रहे थे 4 मीटर पर सेकेंड से, यहाँ पे आप थोड़ा सा रुक गए, फिर यहाँ पे आप चल रहे थे 3 मीटर पर सेकेंड से. तो आपकी वेलोसिटी में बहुत सारे वेरिएशंस आते हैं. अब उन वेरिएशंस को अगर मुझे अकाउंट करना है, अगर उन वेरिएशंस को कंसिडर करना है, तो मुझे जो अपना टाइम इंटरवल है, उस टाइम इंटरवल को बहुत छोटा करना पड़ेगा dt. क्योंकि अगर मैं टाइम इंटरवल को छोटा नहीं करूंगा तो मुझे फिर सीधा सीधा दिखाई देगा कि दिस इज द डिस्प्लेसमेंट एंड द टोटल टाइम. तो बीच में जो कुछ भी हुआ वो सारा, उस सारे का डेटा उस सारे का इंफॉर्मेशन वो लॉस हो जाएगा एवरेज वेलोसिटी में, और वो इंफॉर्मेशन यूजलेस हो जाएगी। मेरे ख्याल से ये पॉइंट सबको समझ में आ रहा होगा। सो इंस्टेंटेनियस वेलोसिटी, this is how we represent the instantaneous velocity. Instantaneous velocity is very small displacement by very small time. Now let's try to solve some example over it and see how that works out. A particle moves along x-axis according to the equation x equals to 2t squared. X equals to 2t squared. Now what does x equals to 2t squared mean? I'll explain it in a moment. Just let me write down the problem. Find out the average velocity between 0 to 4 seconds and instantaneous velocity at t equals to 2 seconds. अच्छा, अब इस बात को ध्यान रखना कि जब भी आपसे एवरेज वेलोसिटी पूछा जाएगा तो हमेशा आपको एक टाइम इंटरवल दिया जाएगा, 0 to 4 seconds, 0 to 3 seconds, 0 to 1 second, 1 to 5 seconds, 1 to 7 seconds. तो जब भी आपको एवरेज वेलोसिटी पूछा जाएगा वो आपको एक टाइम इंटरवल देंगे, दे विल गिव यू अ टाइम इंटरवल। और जब भी आपको इंस्टेंटेनियस वेलोसिटी पूछा जाएगा तो सिर्फ एक मोमेंट ऑफ टाइम दिया जाएगा, ठीक है। तो अगर इस शब्द का इस्तेमाल, अगर एवरेज शब्द का इस्तेमाल नहीं होता और इंस्टेंटेनियस शब्द का इस्तेमाल नहीं होता तो भी आप पता कर सकते हैं कि आपको एवरेज वेलोसिटी बतानी है या इंस्टेंटेनियस वेलोसिटी बतानी है। कैसे पता कर सकते हैं? सीधा सीधा तरीका यह है कि अगर टाइम इंटरवल दिया हुआ है मतलब एवरेज वेलोसिटी, और अगर एक मोमेंट ऑफ टाइम दिया गया है तो इंस्टेंटेनियस वेलोसिटी। नाउ बैक टू आवर प्रॉब्लम. What does x equals to 2t square mean? Let me draw this in white. Okay, so t equals to 0 पे if you put it in the equation, if you plug in t equals to 0, इस equation में अगर आप t equals to 0 डालते हो तो you will get x equals to 0. Now if you plug in t equals to 1 seconds, you will get x equals to 2. Now if you will plug in t equals to 2 seconds, something interesting happens. Particle बहुत तेजी से भागता है. You will get x equals to 8. And if you will plug in, let's say t equals to 3 seconds, then you will get 18. So you know the particle is, you know, every next second the particle is covering larger and larger distance. Fine. Now how do we find out the average velocity? It's actually simple. Finding out the average velocity. Final position, that is position at 4 seconds minus position at 0 divided by 4 seconds, or the position at 4 seconds can be written as 32, position at 0 can be written as 0 divided by 4 seconds, and that will be equals to 8 meter per second. So this is your average velocity between 0 to 4 seconds. This is your average velocity between 0 to 4 seconds. That is the thing. Now, if you want to find out the instantaneous velocity, how do you find the instantaneous velocity? Instantaneous velocity निकालने के लिए आपको काम यही करना है. This is what you have got to do. But you have to take very small difference. As in, we will take t equals to 2 seconds and t equals to 2.0001 second, or I can write it as 2 plus dt. What is dt? dt is 0.0001 seconds. So dt is actually a very small fraction of time whose value is 0.0001 seconds. So the position at 2 seconds, the position at 2 plus dt, let me first remove this. The position at 2 plus dt is going to be equals to 2 times of 2 plus dt का होल स्क्वायर. भाई जितना टाइम होगा उसका स्क्वायर कर देना है, जितना टाइम होगा उसका स्क्वायर कर देना है. तो टाइम कितना है? टाइम है 2 प्लस डी टी. अब मैं डी टी क्यों लिख रहा हूँ, मैं 0.001 क्यों नहीं लिख रहा हूँ? भाई 0.001 हर बार लिखूंगा तो बहुत मेहनत पड़ेगी, इसलिए मैं मेहनत बचा रहा हूँ और 0.001 की जगह मैं डी टी ले रहा हूँ. सीधी सी बात, ठीक है. द पोजिशन एट 2 सेकेंड्स is simply equals to 2 into 2 squared, and that will be equals to 8. Now, how do you find out the instantaneous velocity? In order to find out the instantaneous velocity, we will use x of 2 plus dt minus x of 2 divided by the change in time, that is 2 plus dt minus 2. So that is equals to dt. So 2 plus dt, that is 2 into 2 plus dt ka whole squared minus 8 divided by dt. Now it's our job to expand this. So let's start expanding on it. Some mathematical manipulation is needed. So we are going to have a plus b squared. So that is 4 times 2, that is 8, plus 2 dt squared plus 4 dt and times 2, that is 8 dt minus 8 divided by dt. Alright. Now as you can see, 8 and 8 will get cancelled out, and we are going to have, if you simply divided this by dt, let me take this thing as dt as common, so that would be better. Alright, so what do I do is this, I'll remove this. Okay, so ध्यान से देखना, मैं dt common ले लूँगा and I'll have 2 dt plus 8 divided by dt. So now what I can do is I can cancel out dt and I'll have 2 dt plus 8. Now since dt is very small, it is 0.0001, so I can roughly say that this instantaneous velocity is 8 meter per second. Now मैं नहीं चाहता कि आप कंफ्यूज हो इस बात को लेकर के कि एवरेज वेलोसिटी भी 8 थी और इंस्टेंटेनियस वेलोसिटी भी 8 है, तो हर बार 8 ही आएगा या हर बार एवरेज इंस्टेंटेनियस के बराबर होगा, ऐसा नहीं है. सो इन ऑर्डर टू प्रूव दिस, इन द सेम एग्जाम्पल, लेट अस फाइंड द इंस्टेंटेनियस वेलोसिटी एट t इक्वल्स टू 3 सेकेंड्स. तो ऐसे क्या होगा, जिनको थोड़ा अभी कम समझ में आया होगा या फिर नहीं समझ में आया होगा, वो एक और एग्जाम्पल देख करके इस चीज़ को समझ सकते हैं. So let's move up. I repeat my problem. So x equals to 2t squared. Now we'll find instantaneous velocity at t equals to 3 seconds. Now what do? I take 3 and I take 3 plus dt. 3 plus dt. These are my two instants of time, and dt is very small as in like something small like this. So dt is almost tending to 0. Okay, now what do? In order to find out average velocity, first I'll have to find out the position at 3 seconds, so that is going to be 18 meters, and then position at 3 plus dt seconds, so that is going to be 2 into 3 plus dt whole squared. Now the instantaneous velocity is going to be x of 3 plus dt minus x of 3 divided by 3 plus dt change in time minus 3. So that is going to be equals to 3 plus dt whole squared minus 18 divided by dt. Slight expansion is needed. So 2 times of 9, that will be equals to 18. So why do I need to write 2 here? I don't know. I'll just write 18 plus 2 dt whole squared and 12 dt over here minus 18 divided by dt. 18 and 18 will get cancelled out. We can simplify this a bit. So let's see. I'll take dt common and I'm left with 2 dt plus 12 divided by dt. So dt and dt get cancelled out. and approximately the value is equals to 12 meter per second. So as you can see, this time it is not 8 meter per second and it is not equal to average velocity. So instantaneous velocity हर एक instant पे अलग अलग होती है and it is way different than average velocity. Instantaneous velocity gives us the exact, let me put this in words, instantaneous velocity gives us the exact depiction of motion. तो अगर आपको पता करना है कि पार्टिकल कितनी स्पीड से जा रहा था, किस डायरेक्शन में जा रहा था इस मोमेंट पे, अगर आपको एग्जैक्ट चीज पता करनी है, तो फॉर दैट यू यूज इंस्टेंटेनियस वेलोसिटी. Now as you can see that this is actually very difficult to use. This method is actually very difficult to use. So we are going to use a very simple formula. And what is the formula? Let me write the formula. This is actually a differentiation formula, but I don't need to worry you with differentiation. Just remember the formula. So if your position is some t to the power of n, where n is a real number, we all know what real numbers are, so no problem there, then the velocity or the instantaneous velocity, that will be dx by dt, is going to be n times of t ka power n minus 1. Okay, or if some x is some constant into t ka power n, again c is a real constant, then the instantaneous velocity is going to be dx by dt, and that is equals to c into n t ka power n minus 1. So you see here that we are not disturbing the constant stays as it is, and we are using the first step right over here, so n into t ka power n minus 1. Now let me explain this to you with the last example. हमारा x का वैल्यू कितना था? हमारा x का वैल्यू था 2t स्क्वायर था. अब आपको इंस्टेंटेनियस वेलोसिटी निकालनी है एट t equals to 3 seconds. Good, no problem. So instantaneous velocity will be dx by dt, that is 2 times 2 side में t का power 2 minus 1, or we can say 2 into 2 into t का power 1, or simply equals to 4t. Now कितने टाइम पे निकालना है? 3 सेकेंड पे. तो instantaneous velocity at 3 seconds is equals to 4 into 3, and that is equals to 12 meter per second. तो आपको ध्यान होगा कि इसी तरह से सॉल्व हुआ था. यही आंसर, इसी तरह से नहीं, यही आंसर आया था 12 मीटर पर सेकेंड. If you want to find out instantaneous velocity at some other instant of time, we can put it this way: dx by dt is equals to 2 into 2 into 2 ka power minus 1, so that will be equals to 4t. Now at t equals to 2 seconds, your instantaneous velocity at 2 seconds is going to be 8 meter per second. So you see, it's actually very simple now. All you have to do is use this formula. Let me come back here. All you have to do is use this formula. Use this formula, or maybe this formula. Just there is actually no difference between the two formula. दोनों formula एक ही हैं. बस ध्यान ये रखना है कि जो भी constant multiplied है उसे कोई disturb नहीं करेगा, वो वैसे का वैसे ही रहेगा. ठीक है? So all you can do is use this formula, and then you can find out your instantaneous velocity. Okay? So that's all for this lecture, and we will come up with few more things in the next lecture. So that's all for now. Meet you in the next lecture. Okay? Have a great day.